Okay, in this demonstration, we're going to show how to calculate the enthalpy change of air. The problem is to calculate the enthalpy change of air for temperature rise from 300 Kelvin to 800 Kelvin. And we're supposed to use two different approaches. One is to use the constant specific heat, or to use the average specific heat. The other approach is to use the ideal gas property table. Let's see how we do it with the first approach, using constant or average specific heat. The first approach is to use this equation. We know that the enthalpy change is related to the constant pressure specific heat. So with this equation, if we can find the constant specific heat for this range of temperature change, and we know the temperature change, we can find the delta H. That's the approach. That's the thought behind the approach. So what we need to do is we need to go find the specific heat at the so-called average temperature. That's one way to do it. So you see, our problem involves temperature, pressure, involves temperature from 300 Kelvin to 800 Kelvin. And you can see the constant specific heat. The constant pressure specific heat actually changes. It's different between these two temperatures. So we need to use an average. There are different ways of finding the average. Certainly you can find the specific heat at these two temperatures and then take the average of the two and use that as the average. Alternatively, you can use the constant specific heat corresponding to the average temperature and then use that as the average specific heat. So we're going to use this approach. We are going to find the average temperature, which is 550 Kelvin. This is our average temperature, T average, of these two temperatures. And then we use this as the average specific heat. So the delta H is equal to 1.040 kilojoule per kilogram per K. This multiplied by the temperature change, 800 minus 300 Kelvin, and then the result is 520 kilojoule per kilogram. So that's the first approach, using constant specific heat or average specific heat. Now the other approach is to use the ideal gas table for air, the ideal gas property table of air, and find the enthalpy at these two temperatures directly, and then find the difference or find the change in enthalpy. Let me zoom in a little bit. Okay, so here we need to find the specific heat, or we need to find the enthalpy directly from temperature. We need to find that for the temperature of 300 Kelvin, which is at this point, and we need to find the enthalpy at 800 Kelvin at this point. We can write this directly, and delta H is equal to H2 minus H1, and then H2 is H at 800 Kelvin, which is 821.95 kilojoule per kilogram, and H1 is H at 300 Kelvin, which is from the table 300.19 kilojoule per kilogram. Taking the difference of the two, we can see that delta H is equal to 521 let's round up to 3 significant digits, and then we will have 322 kilojoule per kilogram. Compare the two. Let me zoom out. Compare the two. We see using first approach we get 520 kilojoule per kilogram. Using the second approach we get 522 kilojoule per kilogram. They're quite similar. So that completes our demonstration. The demonstration was to find the enthalpy change of air when the air's temperature changes from 300 Kelvin to 800 Kelvin. And we used two different approaches. One is to use the constant specific heat, or the average specific heat. That's the constant pressure specific heat, which is related to delta H. Alternatively, we use the ideal gas property table to find the enthalpy at the corresponding temperatures directly, and then take the difference between the two.